Welcome to week 3 of Cardiac Interventional. Here are the instructions. And what I want to point out is the reading assignment. So all I have assigned is our pages 29 and 30. I try to keep the reading assignments to a minimum because I know for me anyway, I have to read things 2 or 3 or sometimes even 4 times before I can comprehend and understand everything. So I make these reading assignments small so that you will read them, more than once, and so that you will have, have the time and opportunity for it to sink in. So we'll go ahead and go to the lecture. So for week 3, we are still talking about heart anatomy, and as I've mentioned, we break the heart anatomy down into 5 categories. We've talked about blood flow through the heart. We have talked about the layers of the heart wall and the layers of a blood vessel. And we have talked briefly about the blood pressures of the heart within the chambers and different areas of the heart. This week we're going to focus on the conduction system of the heart. And then of course we still have to talk about coronary arteries, but we will probably start that next week. So here again I just have blood flow through the heart typed out again. If you'll notice though, I do have the pressures in parentheses in green. So the superior and inferior vena cava, remember those are veins, and veins do not have a pulse, and so those are reported as a mean, or that's just another name for average. So the average blood pressure of any vein is about a 5. The right atrium is also an average of about a 5 millimeters per mercury. Tricuspid valve, right ventricle, that is reported as systole, diastole, and then the EDP, which is the end diastolic pressure. And we haven't really talked about what EDP is, and at this point you don't really need to know. Just understand that when you see the numbers in these 3 in this 3 format, then this is systole, diastole, and EDP. Okay, pulmonary valve, right and left pulmonary arteries. That average normal blood pressure is 25/10. And then we got the lungs, the right and left pulmonary veins, the left atrium, which is a mean or average of 10. Mitral valve, left ventricle is 120 systole, diastole of 0, and the EDP is 10 as an average. Then you got the aortic valve, and then the aorta, 120/80. I also want to point out that veins and the right side of the heart is deoxygenated blood, and so that's why I've typed that in blue. And then the blood becomes oxygenated in the lungs, because when we take in a deep breath, that breath goes into the lungs. The blood travels there where that oxygen is waiting for it, picks it up, and then oxygenates the rest of the body. And I have that depicted in red. Okay, so moving on now to the actual conduction system of the heart. The first concept that you need to understand is that the heart generates electricity. And that is somewhat of a hard concept to understand. And so for me, I just had to accept it and go on. So it does. The heart generates electricity, and that electricity can be detected by electrodes that are placed on the skin. And then the machine then detects that electricity and converts it into a waveform. And so that's what an EKG is. So let me just briefly talk about EKG. Here I have the word ECG. And an EKG is electrocardiogram. So an ECG is actually the proper way of writing it, but most people say EKG, and that's because in some countries electrocardiogram is spelled with a K, and so that's just kind of carried over into the US. And so really EKG is actually technically not correct, but that's how it's said, and so that's what we'll go with. But whenever I type it, I usually do use the proper ECG, electrocardiogram. Okay, so within the heart muscle, there are special cells that create that electricity and conduct the electricity. So the first clump of specialized cells is called the SA node, and that is considered the pacemaker of the heart. The natural pacemaker of the heart is the SA node. So the SA node, again, is just a clump of cells that are within, well, it's located within the right atrium of the heart, and that is the thing, that is the structure that actually creates the electrical impulse. That impulse then travels to the AV node. So again, the AV node is just another clump of cells that's located, again, in the right atrium. And its purpose is to delay the electrical impulse to allow the ventricles to completely fill with blood, because the atria contract and finish filling the ventricles with blood, and so the AV node's purpose is to delay that electrical impulse. Then from the AV node, that electrical impulse is sent to the bundle of His. From the bundle of His, as a side note, the bundle of His also could be called the AV bundle, the atrioventricular bundle. From the bundle of His, or the AV bundle, the electrical impulse is sent to the right and left bundle branches. And then that impulse is sent to the Purkinje fibers. Okay, so that is the electricity of the heart, and that's how it travels through the heart. And so the question is, what comes first, the chicken or the egg? And so what I mean by that is, which comes first? Does the electricity come first, or does the actual contraction of the muscle come first? And the answer is the electricity comes first. Okay, it's the electricity, it's that electrical impulse. It is that stimulus that causes the muscles to contract. So the electricity comes first. And an ECG, or EKG, which is the same thing, displays those cardiac electrical impulses. It displays it as a wave. Because of the because of the electrical impulses, that's what causes the cardiac muscle cells to contract or depolarize. So I kind of said that backwards. The cells depolarize. The cells depolarize first, and then that's what causes the contraction. Okay, so here is a picture of the electrical system of the heart, and so let's see, okay, here we go. So here we've got the SA node, which again I said is the pacemaker of the heart. That signal is sent to the AV node, which is here. Now on this diagram, the bundle of His is not labeled, so you'll need to add that to your drawing, but this area right here, right there, that is the bundle of His, or the AV bundle. From there, the impulse then goes to the right bundle branch and the left bundle branch, respectively. So the left bundle branch is labeled here, and it's this pathway here, and then here is the right bundle branch. Then from there, it goes on into the Purkinje fibers. Okay, so as we scroll down here, then we'll take a look at this. So again, the heart generates electricity, and the EKG machine, its job is to detect that electricity and to display it as a waveform. And so here is your typical normal waveform, and we are going to spend a lot more time on the waveforms in the future, but today is just a very, very brief, barely scratching the surface overview. And so here we go. We've got, so the very first deflection is called the P wave, and so that represents atrial depolarization. Remember, the word depolarization means contraction. So here, and then here on the diagram is showing you the P wave. Then you have the QRS complex. So the Q is going to be the first downward deflection after the P. The R is the tall upward deflection, and then the S is another downward deflection. So that is all, that whole thing is the QRS complex, and that represents ventricular depolarization or contraction. Then you have the T wave, which represents ventricular repolarization or relaxation. So here again we have just a typical EKG strip, and so what you need to do is print this out several times and just simply label the major structures of an EKG strip. And so so here we'll go through this here. So here is the P, Q, R, S, T. This is a P, Q, R, S, T. 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 And so you need to do this over and over and over again. P, Q, R, S, T. And when you have downtime and you're just sitting around in the hemo room, maybe you can just start watching the EKG strip and just in your head go through, when you see these bumps, go through it in your head. Q, R, excuse me. That's not right. Here we go. P, Q, R, S, T. P, Q, R, S, T, and so on. So you'll want to print this out and just go over it and over and over and over it. Another way you can do this is if you'll just kind of flip through the pages of chapter 3 of your book, almost on every page there is an EKG waveform. And so with every picture, any picture of an EKG that you see, you can just practice identifying those major structures, the P, QRST, P, QRST, P, QRST. And again, as you flip through the pages of chapter 3, almost every single page has an EKG on it, and so you can just, kind of go through it that way. Okay, so that's about all for week 3. I feel like we are moving kind of slow, but yet this is so much information, and it is so important. You have to have this this fundamental foundation for all of these things before we can move on, because it does get much harder. We will be tackling the EKG in much more in depth. We will be tackling the pressures of the heart much more in depth and the waveforms associated with them. And then, of course, we still got the coronary arteries to tackle. So it's a lot of information. I am trying to go slow these first couple of weeks on purpose so that you can master this information before we move on. So look forward to seeing you next week.